Welcome, ladies and gentlemen. Thank you for joining us. Sorry for the slight delay. We just had many people logging on rapidly at that last moment there. We wanted to get in as many as we could. We'll cover a few things today. A lumen per watt update. This is pretty much very current information, as current as we can get from LED manufacturers and the like. Cost per lumen update. A lifetime data update, which has really pushed out much further than I personally had anticipated and much further than many had anticipated. And then we're going to do a little bit of a commercial and talk about some of our products, our LED Troffer products specifically, and a little bit about their features and benefits. So let's get started. Lumens per watt update. What we're looking at here is just a simple chart that shows pretty much where cutting edge is on raw LEDs. Now today, in the laboratories and in the manufacturing facilities of the leading LED manufacturers, they are able to produce upwards of 200 lumens per watt in the laboratory. Now, those are not commercially available. These are not mass produced, but they will be soon. The trend has been moving up and up. The very first time we showed this slide, I guess about 2 years ago, and we've updated it regularly since then, we were looking at 100 lumens per watt in the laboratory. So we've doubled that in just about three to 4 years. Commercially available, however, today, I could actually place a purchase order for 160 lumen per watt LEDs and have them delivered. So this is what's actually available to manufacturers like MaxLight. And again, these numbers just keep growing. So you read about numbers like 160 lumens per watt, 200 lumens per watt in newspapers and in trade journals and the like. And then you buy a fixture that's 80, 90, 100 lumens per watt. And this explains a little bit about how we get from 160 to about 100 today. And it's basically to maintain the longevity and performance of the product. We thermally derate it. MaxLight generally under drives the LEDs 25 to 30% on our products. There's many white papers out there that show that this thermal derating, this under driving of the LED, extends the life and causes the lumen depreciation to fall at a much slower pace. And MaxLight applies this to all of our LED products. And then we have some optical efficiencies where we've got to move light and get it to the right places. Now this number has shrunk through the years. Optical losses were as much as 12-15% a few years ago, but not just the LEDs have made major breakthroughs in performance, but lensing and the like and other optics have really moved forward in the last few years to support this general lighting, this white light trend in LEDs. And then we have driver efficiencies. You know, every driver consumes some power. We try to keep it about 10% or less, but typically out there it could be 12-15%. And what you're left with after these thermal derating or underdriving, the optical efficiency and the driver efficiency is you get from about 160 to about 100 lumens per watt. And you know, the latest fixtures, and we'll review this in a little bit, are now over 100 lumens per watt. Now bear in mind that although I can buy LED chips that are 160 lumens per watt, I have to make sure that they are available with LM80 data in order for MaxLight and other reputable manufacturers to make sure that the LEDs are quality LEDs. We need to see some data. The LM80 data has become the industry standard, and it takes 6,000 hours, that's over 8 months, to accumulate that data. So although the cutting edge might be 160, even approaching 170 today, it's going to take me 8 months before the data supports that, and I need that data in order to run the LM79 and to come up with our lifetime. Now, cost per lumen. Cost per lumen is something that we've all been tracking for a long time. Now this chart is a little busy. Many of you may have seen it through the years. It's Hertz's law, and it's been remarkably accurate. Let's jump to the next slide. I want you to focus on the purple dots. The red flux is also growing, but for our purposes today, we're going to focus on general lighting, white light. And as you can see, that the cost per lumen on the white light has been decreasing. And at the very same time, the lumens per watt, the light output, has been increasing, and this will continue. Hertz's law is very similar to Moore's law, which predicted similarly that computer CPU chips will grow in power and shrink in cost, and we've all experienced that. Our PCs are more powerful than ever, and either at the same cost or a lower cost, certainly than the first PC that you bought. Lifetime data. Now, we've got this information from Cree. We have another from LumaLED, Philips LumaLED. This is, well, it's quite remarkable, actually. actually. What we see here is that in the first 5,000 hours or so of this particular chip, we have reverse degradation. The chip actually increases slightly in its lumen output in its first 5,000 hours, which is, a minimum of 10% of its life, and this data shows much smaller portion of its life. What this is showing is that at 40,000 hours, we haven't even approached 5% light depreciation, and this is actual measurements. This is not extrapolated information. This is actual data. The next one here is on the Rebel chip, the Lexion Rebel chip made by Philips, and it's basically what it's saying is, it's saying a lot of things, but basically extrapolated, you can see that we're approaching 150,000 hours at L70, a 30% depreciation from its initial light output, and 150,000 hours later or so, extrapolated out to 150,000 hours for a 30% depreciation or an L70 number. Most actual data that's come out, not extrapolated, but actual data, almost all that I have seen have shown that the lifetime data published is very conservative, and almost always the actual testing exceeds the lifetime extrapolation. So these numbers are very, very encouraging. Some of you may have noticed that literally overnight, some manufacturers started taking particular LED fixtures and went from marking the product and advertising the product as 50,000 L70, and overnight went to 100,000 hours L70. And there's a lot of data that supports that. MaxLight has still maintained a 50,000 L70 lifetime, which is an actual bare minimum lifetime at a relatively high temperature. So we certainly anticipate a large extension in the life output, and certainly will meet or exceed our published life data. We'll talk about these very same LEDs in a particular set of LED Troffer fixtures, starting first with an edge-lit Troffer. MaxLight makes these edge-lit Troffers in 3 sizes, 1x4, 2x2, and 2x4 sizes. For those of you not familiar with the term edge-lit, these devices are lit up with LEDs around the perimeter of the fixture, of the luminaire, all pointing towards the center of the luminaire. And it makes for a very evenly distributed lens. Frankly, much better than most fluorescents that are out there. The depth of this edge-lit fixture, including the driver on its back, is less than 2.5 inches, much slimmer than the typical fluorescent fixture in the same size. The LEDs that we're using are all rated with LM80 chips. We only use chips that have at least 6,000 hours of life data to support the manufacturer's claims. The power factor on these, although many don't really concern themselves with power factor, it is very important with the utility companies, and we are running 98% power factor on all of our Troffer type fixtures, and at least 90 plus on all of our LED fixtures. These are a universal voltage, similar to a universal voltage ballast. These have a universal voltage driver from 120 to 277. That includes the oddball 208s and 240s in between. These fixtures are dimmable with 0 to 10 volt ballast dimmers. Up to 20 panels and a master can be linked together to operate as a synced unit. In other words, you can run 20 fixtures and dim simultaneously 20 fixtures with one dimmer switch. These products run cool. They're over-designed when it comes to the thermodynamics. As mentioned earlier, the temperature has a huge impact on the life of LED products. Most are running their temperatures, their assumed temperatures, at 25°C, and when you are operating these fixtures below that temperature, generally it extends the life of the fixture. Generally it slows down the lumen depreciation. Additionally, as these fixtures are dimmable, dimming also pushes out the lumen depreciation curve, so that you'll get beyond the 50,000 L70. We have a 50,000, at 50,000 hours, that's 17 years operating 8 hours a day. The edge-lit, being one of the latest fixtures to be DLC listed, has some of the latest chips that we are using. And as you can see, we have hit 90 lumens per watt with this edge-lit fixture. This particular 2x4, which is one of the latest to be adopted into this family of products, is actually over 100 lumens per watt. Know that every update, every single new product is using a later and later chip, and the lumens per watt will just continue to increase. As I mentioned, there's dimming. MaxLight offers a low-cost dimming with a handheld IR remote, so you have another option along with the 0 to 10 wall dimmer. And for a low-cost wall dimmer, we also offer a holster that holds that wireless IR dimmer to the wall. And we also have a surface mount kit. The surface mount kit acts like a frame around a picture. Once the luminaire is mounted to the surface mount kit, you can mount the fixture to a wall or to a non-grid style ceiling. We'll talk a little bit now about direct lit troffers. Now, these troffers, as opposed to the edge lit, where the LEDs are around the perimeter and pointing towards the center of the fixture, here the LEDs are on the back of the fixture, pointing straight down to the floor from the ceiling. So hence direct lit. These also are available in 1x4, 2x2, and 2x4 sizes. Now the depth of these particular fixtures are about 4 inches, still the same or less than the fluorescent counterparts that we are replacing. We have the same dimming controls, using the same type of chips that give us a nice uniformity. Now, these fixtures are DLC listed for those of you interested in the rebates associated with DLC approval through your local utilities. Know that the 2x2 and 2x4s are already listed, and the 1x4s are currently in the process for being listed. Here's some additional specifications. You will all get a copy of these following our presentation today, where you can review the detailed specifications at your own speed. The options and accessories available for the direct lit include, in addition to handheld remote, holster, and surface mount kit, also include a battery backup module. Now, this is an integral part of the fixture. The backup module is not something that can be added in the field. This is done here at the factory in New Jersey, and it's a entire fixture. And it does meet the true definition of emergency battery backup, where it meets the minimum lumen output and run times. Now, I'm very happy to be able to talk about the new retrofit kit. This is something that we've been working on for a few months now. This is all preliminary data that I'm going to share with you. You're the first to see this information, and we look forward to making these products available in the market in the very, very near future. Meanwhile, I'd like to point out to you the 2 different types of retrofit kits that we will be offering. This first kit is it's a plate, 22 gauge steel plate that houses everything, including the driver, the LED strips. They can be connected very simply with a Molex connector to the driver. We supply an S-hook so that while you're doing the wiring, this retrofit kit hangs in place. Once the wiring is connected, push the retrofit kit up into the fixture and zip in 4 screws, which are already mounted to the plate. So I hope that I'm articulating it well, but know that this is very, very easy to install. The LED strips, which in the 2x4 version is 4 strips, is held together with a high-end thermal glue so that all the heat generated by the LEDs is transferred to this large plate. We have kits available for 1x4, 2x2, and 2x4 sizes, and these will hit the market at a very competitive price, designed specifically for ESCOs for very, very quick installation. The other type of retrofit kit that we will be offering to the market are actually the strips and driver. These will be used largely in the OEM market, but they will also be available for ESCOs and retrofitters out there. In this case, what you have are the PC boards and the driver pre-wired, and you mount them into the fixture as opposed to just 4 zip screws. This is a little bit more labor intensive, but you'd be surprised at how little labor. This was very well thought out. They are available in 2x2 and 2x4 sizes. Both, I should have mentioned, can be dimmed with a 0 to 10 volt dimmer. And because we can't ensure how they'll be mounted, we can't ensure where they'll be mounted, these will come with what we call thermal dots. These are dots that are set at a preset temperature. It's really, look at it as a one-way thermometer. These will stay white as long as the temperature they're exposed to stays under the threshold. If it exceeds the threshold by even a small part of 1 degree Fahrenheit, the dot will turn black. And then we know this is a bad application. For those of you who are familiar with the MaxLight HiMax high power CFL products that we've enjoyed selling through the years, we will be using the same thermal dots for this retrofit as well. So this is so that we all know whether the application is compatible or not before we spend a lot of time and effort in doing the installation. You should know that these products can be used with motion sensors and occupancy sensors, shade controls, daylight harvesting, and the like. The last category of troffer that we'll speak about today is our specialty MRI LED troffer. For those of you who may not know, MRI lighting requires that the light fixture, the luminaire, have no magnetic parts, using only non-ferrous metals. Another requirement for MRI applications is that there be no AC power within a certain distance of the actual MRI machine. So with MaxLight's MRI LED troffer, we use only non-ferrous metals, no magnetic parts, and we have the driver set on a 25-foot extension. Typically what's happening in these applications is they're mounting the light fixtures where they're needed, and they're bringing the driver and mounting that in the same room where they operate the MRI machine. So the AC power is away from the machine and no magnetic parts are near the machine. This has been a pretty successful niche product line for MaxLight, and not just in the MRI rooms, although we get the door open and our foot in the door with this MRI specialty fixture. We have been very fortunate and been able to help these medical institutions light up their non-MRI areas with our other troffer products. So I'd like to mention a small plug that we'll be meeting in about a month from today on the 20th of December. We'll be covering small outdoor commercial LED fixtures, and we hope that you can join us then. A registration will be available very soon. For those of you interested, you can go back and look at previous webinars. Like this one will be shortly. All of our webinars are posted to maxlight.com. You can also find many of our webinars and other video material at YouTube at the MaxLight channel. And please, when you have an opportunity, visit university.maxlight.com, where you'll find very non-commercial, pure educational information, as well as very commercial information and more in-depth product information. Thank you all for joining. As typical, we will leave this session open for questions for a few minutes, and we will send a list out of all the questions that have been asked during this webinar, along with the answers, in the next day or two. Thanks again for joining.